Today I will discuss about Bartlett's test. Hello, good evening. I am Dr. Nazrul Islam, Associate Professor, Department of Geography, Kuchbihar, Panchanan Burma University. The Bartlett test is a statistical test used to assess whether the variances of two or more groups are equal. It is an important assumption test for various statistical analyses, such as analysis of variance, that is ANOVA. Bartlett test is sensitive to departures from normality, so it is crucial to check the normality assumption before conducting the test. Now we will perform Bartlett test with the following hypothetical data. For example, suppose we have three groups A, B and C, and we want to test whether their variances are equal using Bartlett test. So we have three groups of data, group A, group B and group C. The null hypothesis is the variances of the groups are equal, and the alternative hypothesis is at least one group has a different variance. So Bartlett's test is calculated by the following steps. First, calculate the sample variances of each group using the following formula. Here S square represents the variance of the samples. N is the number of data points in the group. Xi is the represents each data point in the group. Bar X is the mean of the group. So for the group A, the mean value is 18 and variance is 22.5. Similarly, we calculate mean and sample variances for group B and C. For group B, the variance is 18.7. For group C, the variance is 19.3. Step 2. Now we calculate overall or pooled variance. Pooled variance is also known as combined variance. This is the formula for determining pooled variance of the data, where N, A, NB and NC are the sample sizes of group A, B, C and C respectively. By putting the value of each, we can find the pooled variance as 20.1667. Here all the group have 5 number of population and their variances are given here. Step 3. Calculate the test statistic. Bartlett's test statistic is calculated by using the following formula, where T is the Bartlett's test statistic, N is the total number of observation, K is the number of groups, Ni is the number of observations in the ith group. See, S square P is the pooled or combined variance. S square I is the sample variance of the ith group. In this formula, In represents the log normal distribution. In our example, total number of observation is 15 and total number of group is 3. We have already calculated variance of A, variance of B, variance of C, and pooled variation. Substituting the value in the formula, we calculated t value. This is the detailed description of the t calculation, and after calculating we get the result as 0.0261 approximately. Step 4. Now we need to compare the calculated t-value to the critical value from the chi-square distribution table and p-value with k-1 degrees of freedom at a chosen significance level, that is 0.05. The critical value is approximately 5.99 and p-value is 0.904. As the calculated value is less than the critical value and p-value is larger than the selected alpha, that is 0.05, we fail to reject the null hypothesis, suggesting that there is no significant difference in variance between the groups. In other words, the variances of the groups are more or less equal. By using the Python and by using this code, we can easily get the result of Bartlett's test statistic and also p-value. Now, after obtaining the result of a Bartlett test, the next steps depend on the context of your analysis and purpose of the conducting of the test. Bartlett test is typically used to assess whether the variances of two or more groups or populations are equal. If we fail to reject the null hypothesis, that is, variances are approximately equal, you can proceed with parametric tests like t-test and analysis of variance, that is ANOVA. If you reject the null hypothesis, you should consider alternative parametric tests such as Wells t-test for comparing means, or non-parametric tests like Pascal-Wallis test for comparing distributions. This is the screenshot of Python code, and this is the result of Bartlett's test statistic as I have mentioned in the previous slide. So thank you for watching my channel. Merci become.